Hello everyone, in today's video we are going to cover section 7.3, formulas involving polygons. After studying this section, you'll be able to use some important formulas that apply to polygons. Looking at naming polygons, most of the polygons we've encountered have special names like those given in the following chart. For instance, a triangle has 3 sides, quadrilateral 4, pentagon 5, etc. If I want to name any polygon, I can name it by the number of sides and attach a gon to the end. So a 20-sided figure would be called a 20-gon, 30-sided would be 30-gon, so on and so forth. Looking at angle sums of polygons, I can determine the measures of the angles of a polygon based on how many triangles I can create inside the polygon from the diagonals. Now, a diagonal is a line segment that comes from a vertex to a non-adjacent vertex. So for instance, in my figures to the right, I have a pentagon, a 5-sided figure. In a 5-sided figure, I can draw 2 diagonals, which would make 3 triangles. I know one triangle is 180 degrees, so 3 triangles would be 540 degrees. So a pentagon is 540 degrees. This works for every polygon, therefore we can use the following theorem. The sum of the measures of the angles of a polygon with n sides is given by the formula n minus 2 times 180. So I take the number of sides, I subtract 2, and then multiply that number by 180. Looking at exterior angles of polygons, so we know the interior angles of a polygon are the angles that are inside the polygon, while the exterior angles of a polygon are the angles that are outside of the polygon. Now, Theorem 56 tells us that if one exterior angle is taken at each vertex, then the sum of the measures of the exterior angles of a polygon is 360 degrees. So every polygon's exterior angles will sum to 360 degrees. We can have a triangle, a square, a pentagon, an octagon, any polygon, they all will have their exterior angles equal 360 degrees when summed together. Now looking at diagonals of a polygon. So again, a diagonal of a polygon is a line segment that is drawn from a vertex to another non-adjacent vertex. Theorem 57 states the number d of diagonals that can be drawn in a polygon of n sides is given by the formula number of diagonals is equal to n times n minus 3 divided by 2. Now looking at our sample problems, we have problem 1. Find the sum of the measures of the angles of the figure to the right. Now my figure to the right is a pentagon, or a 5-sided figure. I know the sum of the interior angles is equal to n minus 2 times 180. N will be replaced with 5. 5 minus 2 is 3, so 3 times 180 is 540 degrees. So the sum of a pentagon is 540 degrees. Now looking at problem 2, find the number of diagonals that can be drawn in a pentadecagon. Now a pentadecagon is a 15-sided figure. Penta meaning 5, deca meaning 10, put them together and you get 15. Now I know the sum of the diagonals is equal to the formula d is equal to n times n minus 3 divided by 2. N will be replaced with 15, so 15 times 15 minus 3 divided by 2. 15 minus 3 is 12. 15 times 12 is 180. 180 divided by 2 is 90. So the amount of diagonals that can be created in a pentadecagon is 90. Now looking at problem 3, what is the name of a polygon if the sum of the measures of its angles is 1080? So I know the sum of the angles of a polygon is equal to the formula n minus 2 times 180. This time I'm not given the number of sides, I'm looking for it. So I'm given the total measure of all of the angles, which is 1080. So that's going to replace s. So 1080 will equal n minus 2 times 180. I'll divide everything by 180. 1080 divided by 180 is 6. So n minus 2 is 6. I'll add 2. So my number of sides is 8, which is an octagon. In today's lesson, we learned the sum of the interior angles of any polygon is given by the formula s equals n minus 2 times 180. The sum of the exterior angles of any polygon is 360 degrees, and the number of diagonals that can be drawn in a figure is given by the formula d equals n times n minus 3 divided by 2. That's a wrap on today's video. We'll We'll see you in the next one.